So he's Chris, I'm Dave, nice to meet you all. Yeah, we're here with the Advanced Visualization Lab, we're part of UITS. Our role in the university is to support students and faculty and the staff here. How to help them use technology to do the work that they need to do. In particular, our group is focused on visual technology, and that can be very broad. So for us, that means anything from making charts to virtual reality to building displays like this, advanced media capture. It's really anything that is visual. And our whole job is to help people like you use these tools to do the work that you need to do. So if you have a project that you think could use this kind of gear, or could use some expertise from us, then just reach out and we will help you, because that's what our job is. So today's agenda, we're going to start in here with this display we call the IQ wall. We have one of these over in Levy Hall that I'm guessing you see from time to time. And then we will walk over here and see science on a sphere display, and then we will close next door in the Innovation Center, where you'll see a couple of virtual reality devices and the Microsoft Hololens for augmented reality. So, Chris Eller is going to take us on a tour of the wall at SOS, so I'll just let him take it away. And yeah, feel free to interject with questions.
Absolutely, yeah. This can be bi-directional, which is wonderful. So yeah, here's the IQ wall. We built the IQ wall that's in the Lenny Hall Viz Lab up on the 4th floor. I think it's 4016, that room. Has anybody seen that one or used that one yet already? Okay, yeah, fun one.
We have class in this room.
Oh, you have glass up there. That's perfect. Well, one of the big differences between these two walls is this one's higher resolution, but that one's capable of stereoscopic 3D stuff. So there's a bit of a trade-off right there. Yeah, we built 15 IQ walls on 3 different campuses at IU, hopefully maybe a 4th one coming online in a little bit. But of all those walls, only 2 of them are capable of stereoscopic 3D display. The one in Lady Hall, and the other one is in the Scholars Commons, which is in the Wells Library. So your IQ wall doesn't yet have tracking, which is critical for virtual reality, but I think it's coming at some point. We just wanted to get it up and running because we did the main installation of that the week before classes started again, so there wasn't a whole lot of time to add some of these extra parts. This wall is not capable of stereo 3D, so and it's mostly used for presentations, kind of like we're doing right now. So this one isn't really for virtual reality. We use it for information visualization, scientific visualization, InfoViz, SciViz, DataViz, any kind of viz. Sometimes we just put a World Cup up there, you know, when the game is going on, or the Olympics, because we have some, staff members that were like, hey, or basketball's playing or whatever. And that's the neat thing you can do with an IQ wall, because it's really, so right now we're just showing slides, right? But it's just a big display. The computer doesn't know any different. It just sees one screen. That's the really cool thing. This one's just at 42 million pixels. This resolution is 10,080 by 4200. So that's not too bad. You have lots of pixels available for all of your InfoVizy type stuff inside Viz and DataViz, all kinds of bits. So we were actually going to show you some of the work that's been done at CNS, as well as for the Places and Spaces, Synapse type stuff, as well as some other work from other researchers. So we'll go to the one that, any questions so far? No, all right. We'll go to one of the pieces that isn't from your group. So, we've got astronomers at various institutions that are generating tremendous amounts of visual data. Though they're not getting it from, searching through texts or by doing analysis of systems or something like that. They're doing it by pointing massive telescopes at the sky and taking pictures. Some of these pictures are quite large. So we'll take a look at one of these. This is only a 54 megapixel image, but taking the Cygnus loop right here. So there's all kinds of information here for astronomers and astrophysicists. That's interesting. So that's the other part that's important, is metadata. Metadata. It's good stuff. So once you've got the imagery, you just kind of want to see it a little bit. You just want to look at the images. Now we hosted the astronomer here last last academic year for part of the themester setup, and this room was packed. There was no room for, there was no sitting room either. People were sitting on the floor, and it was just crazy. Yeah, so we can start to dive in to the image. Now some of this grain here, it's kind of unfortunate that to us it appears grainy, but these are artifacts of the imaging instruments that were used on the telescope and various other conditions. And these colors, of course, are not what we see. And it's not the way that these things appear in the night sky. These are often because different filters are used on the camera. It's like, okay, what is just hydrogen? So they put a filter on there just for hydrogen. And then they'll use one color for that. Where's all the oxygen? Where's all the, I don't know what other color filters they use. You got O3 and all this other stuff. So they might stack 2, 3, or 4 filters, and they composite all those images together. So the colors in here mean something. They're a visual key for information that the researcher can extract out of the image. I think it's just pretty, because I don't know what it means. But when you see it on a big wall like this, it's pretty cool, isn't it? You see you taking pictures and video and all that. But, so this is an example where resolution, right? You've got so many factors in your visualization. You know, how many variables am I testing over? What are my sources? How deep am I doing my research? How big is the picture that you're doing? So that's just some scientific visualization. We also have one of the other maps that you guys have done, or somebody has done here. This is from one of the Synapse maps. Mapping graphene science development, so it just pops up like this initially. But, you know, of course, like many of these other things, we can start to zoom in. This one's a little, not quite as smooth as that one, but it's just different software. Because at these high resolutions, I don't know if I can find a happy medium here. We'll just go one more. All right. At these high resolutions, sometimes software behaves exactly as you expect it to, and sometimes it's a little unpredictable. And that's just part of you know, being out on the edge of technology that we are with these walls, right here. But you know, you've got rich, dense information, so of course you can visualize that right there. Questions, comments, thoughts? Yes. That's you just. It's just wow.
So the edges are not weighted over here.
I'm sorry.
The edges are
Yes.
not weighted. Are they like you have to weight, or it's just single line? The lines which is
Within here?
yeah.
I have no idea. I'm sorry. We'll have to. Yeah. So here's about the base maps and information. This was taken off of the synapse.org website. So, and there are people here and over in Ladino who worked on a lot of these, so I'm sure you can find the author. They're probably just down the hall. Or at least somebody worked with somebody who worked on this. Because this project, the Places and Spaces project, has been running since, what, 2009? 2008?
Older than that even.
Older.
Yeah, we're on iteration 14, I think, right now.
Yeah, it's been going on for quite some time. So yes, they may be rated, they may not be. I don't know, I'm sorry. I'm just a bus driver. Okay, let's stop. Then we also have some more, you know, interactive is kind of a tricky comment in this. We can, of course, you know, move and get the data to change and react, and it'll recalculate what it's doing. But this is a data that's coming in real time. And right now I have it set to show wind speed at the surface of the Earth added with temperature overlay added on as well. And this is just a fun one. At this resolution, it's a little sluggish, but at lower resolutions, it's quite responsive, and it's a neat way to explore and figure out that, you know, why is it relatively warm now? And you can see that, you know, the wind speeds are bringing up air from down south of us right now. Yeah. So it's an interesting way to see what's going on with that. Now, finally, from way back in the day, 2007, Bruce Kerr, who I hear is back in town, had worked to process a bunch of connections and frequency of edit on Wikipedia or various Wikipedia articles. So it's got to think. There it goes. Right there. So now there's a legend on here which I read it and figure it out, and then I forget what it means. So we'll zoom in a little bit, and the web software that's serving this out for us will retile another layer of resolution so that we'll be able to, when the tiling catches up out here, we'll be able to read what the legend is. But have any of you seen this?
Yes.
Before, of course, there's the poster that was down in the basement of the library for many years. Did it move over to Letty Hall? There's a huge wall poster.
Actually, Bruce gave us talks last week.
Oh, okay.
Yeah, so he presented this map.
She already did it, yep. But not on our big wall.
No. Where do you see it?
Let's see, did I roll it the right way or the wrong way? We're good. Try to dive in a little bit. So one of the things that we like to point out with these large displays is this idea of details within context. So when you're looking at data sets or related information that's very dense, now of course it'll tile around. To be able to read what's going on here, you generally have to zoom in to get the details, but you no longer have the context. So on a small screen, then you zoom back out so you can figure out the context, but now you can't read the details. So by having such an absurdly large display at absurdly high resolutions, now you can read those details and see the context within that contains those details. So you don't have to do all kinds of shifting of gears in your brain while you're trying to understand what's going on right here. So details within context. So this is something, of course, that the IQ wall that you have in Letty Hall can do. The nice thing is when the room's not in use or not booked, you know, there's a keyboard and mouse right there. You can just log in. Your IU credentials will work. It would be a massive screen, and you can do some of your own projects right there. Now, I understand that some of you are going to be presenting or doing some end of semester presentations. Is that going to be over there or over here? In here, okay. So if you want to kind of optimize your presentation, we're happy to give you advice on that if anybody wants to contact us about that. It's really, you know, if you're going to be doing, say, PowerPoint, a lot of people put things in PowerPoint, that's fine. We have a template that will then fill the screen so that it looks right. And we can also give advice about how to craft your PowerPoint such that you can make good use of the resolution of the screen. A lot of people are used to having an idea on a slide, one idea per slide and moving through it. Whereas with this much space, you can sort of aggregate ideas, related ideas, onto fewer slides and just change parts of the slide as you move through. A good example spatially that works is sometimes students from interior design, architecture and interior design will give presentations. So when they're, you know, they have a floor plan, and then they have views, render views and camera views in there. So they would just leave the floor plan up, and then it's like, here's the first floor, the second floor, and they would show different views while leaving the floor plan there as they went through fewer slides. Or they would be able to aggregate multiple views on one slide instead of the floor plan. And it made it, they were clicking through slides less frequently. And the people, the audience was able to just process it. It's that context. The resolution provides the context. So we're happy to help you with that. And of course, you're more than welcome when the room is not booked, like we've booked it right now. When the room is not booked, you know, come on over on the bus or ride a bike or whatever, you know, come on in. And you can just, this keyboard mouse usually sits just around the corner right here. You can pick it up, take it over, set it right here, Control-Delete, log in. It'll take a while. The computer is a little old. We're working on, it will be freshened here in, well, not in time for your presentation, so just be patient. This computer's been around since before you came to school here, some of you. But we'd love to have you come over and, you know, refine your presentation and practice if you like to practice and get ready. You know, you're more than welcome to use this facility if it's not already booked for something.
Yeah, I would especially recommend that if you're doing interactive pieces or something like that, it's a really good idea to test those things on this display to make sure that it scales up so that people can see it and that it looks correct on such a giant screen.
Yeah. And we even recommend considering adjusting your presentation to the fact that it is a huge screen. So instead of just full screening everything, spread things out. That's an option, is to provide what we call multimodal presentation instead of a single mode presentation like a big PowerPoint, which you can simulate multimodal in there, or you can just be real multimodal. I'm running that simulation over there. I have that graphic over there. I have a website that I'm referencing right here. And you can just move between them and kind of spread out. Yeah, so you know, there's no wrong way to use it, but we would love you to feel free to come in and use it when it's available. Now, do you have any questions? Not yet. You will. You will, and you know how to get a hold of us, and that's okay.
I have a question.
Yeah, you have a question. Yes.
If I'm going to present on this display, what computer can I use to do so?
You have 3 options. But we really want to encourage the big one. Because your other option, your first option is this large machine. We call it Hydra. So using Hydra, you get the full resolution and the full size of the screens. But if you don't want to use Hydra and you want to, say, plug in or use this computer right here, we can just send that machine right there, but it only goes to the center 16 tiles, and it's only high definition. This is HD being scaled up 400%. So you lose some resolution. Alternatively, if you've got, say, special hardware or special software on a laptop, you have an HDMI cable, we usually have adapters around, but sometimes it's a good idea if you have your own adapter. You can plug in your laptop here then to run your special software or whatever you need, and that can be routed up there as well. So yes, you can use Hydra, you can use your own laptop, you can use the PC that's right here. Your laptop, of course, can be any operating system as long as it puts out a properly formatted 1920 by 1080 video signal that can plug into, that an HDMI cable can plug into, then you're fine. You can use whatever you want.
The laptop also will be scaled up, so you only get full, proper, high resolution if you use the big computer.
Yeah, if we do Hydra, yeah. Otherwise, you're 400% scaled up. And if you're just going to run a PowerPoint, might as well run it on Hydra. Now, with that formatting for the PowerPoint, because we have such tremendous resolution, oftentimes PowerPoint actually works at relatively low resolution. So if you have images, graphs, charts, anything else that you've generated, you can generate those at a very high resolution and use our PowerPoint template, so when you put them in there, they retain that detail. Otherwise, they get scaled down. And then you put it in here, and it gets scaled back up again, and of course, to scale something down, you get rid of data. And then when you scale it back up, you kind of have to make it up, and it doesn't really look that correct or good. So yes, so when you do present, you can, of course, you're more than welcome to use Hydra, you can use your own laptop, or you can use the PC that is here. All of it, you know, both Hydra and this PC will respond to your IU credentials. You just Control-Delete, log in, put your credentials in, you'll be good to go. Excellent question. And another one, please.
I have a question regarding the software you're going to use is Tableau.
Mm-hmm.
So how does Tableau work books, being presented here? Like, is it okay? I mean, like, we have scaling up and scaling down. So if you want to show the interactivity within the world, when you bring the sheets, that will create for each visualization. So, I mean, would we approach it in a different way, or how should we work?
Well, if licensing permits, we can install Tableau on Hydra, and then you would need to test, of course, if your files would run. So I don't know if we have Tableau on here.
We have at times. I don't. If we still have it on this computer, it's probably several versions.
An old version, so we can look at installing the current version of Tableau on
Would you
here.
be using Tableau Public or the
yet to know customer?
We have yet to know from the client because the client hasn't yet, we haven't had a meeting with the client. Mostly, I guess,
So public,
it would be
I'm not
public.
sure will be the answer, so it's public.
Okay. Well, I mean, we have a computer right here. Should we pull up something on Tableau Public and see how it reacts? Okay.
Please.
But you just showed us that we can connect our system laptop.
Yes.
If it's staying a laptop, it will be projected automatically.
Correct.
Yeah, that's
Correct.
another
Absolutely.
idea.
It's just like when you're in a classroom that has a projector and you plug in and it just goes up.
Yeah, but
Same
if we
idea.
need it outside, it just isn't.
Yeah, it just would only be a normal HD resolution. And that's a great question. And that's a good Dave question too. He's our software person. I carry the wrench and the hammer and do the hardware. And some stuff.
I just clicked on this at random. I don't know what it's supposed to do. Looks pretty cool.
Is it thinking?
It is thinking.
Yeah. And sometimes.
It's like nesting, brushing.
Okay. So Control Plus should zoom that up.
Yeah, so this is a good tutorial. So when you load a website, you know, by default it would look something like this.
So, one question I have. So usually in the PowerPoint we get two versions, 4:3 and 16:9. So for this kind of thing, 16:9.
No.
No? And we need more.
2.4 to 1 or 21:9. It's an unusual aspect ratio because, so in an array of displays, so each display is 16:9. So if you extend your array n by n, you will retain the aspect ratio.
Yeah.
But this is n by q, you know, because we are 6 wide and 4 high. If we had added 2 more rows, or, well, if we had added 2 more rows or had 2 fewer columns, then it would be 16:9, but it's not. It ends up being about 21:9, which is just odd. But the PowerPoint template that we can give you is set for the correct ratio as well as the highest resolution that PowerPoint supports. We found there is a limit. Yeah, no, very good question, very good question. So the cool thing is you can really optimize a presentation for this display. The unfortunate thing is there aren't any other displays around that have this same aspect ratio. So you're optimizing it for one event, but if it's a final presentation, that's a good reason to optimize for wherever you're presenting. Yes?
I would say the verdict is in if you're using Tableau Public, it seems to work fine. If you're using Tableau Pro, then as with all things, we'll just have to install a new test and find out together.
And using it will probably be, you know, we have several things open right now. They're all taking processor and memory, and you wouldn't do that. So it'll be a little bit more responsive. We also of course, have all the major web browsers on here. So if you find that it's a little better in Chrome versus Firefox, that's fine. You can start with Chrome. Yeah, and we can install any software on here that's compatible with the system, and then we have a license for if it is licensed. If it is, you know, if it's a free open source license or anything like that, that's fine. We're happy to. But if it does need to license, then we'll need to either some sort of key or license file or something.
All right, do we want to rent the Wi-Fi today? Is that right?
Yeah.
Yeah.
Okay,
Yeah.
in that case, we better move.
Yeah.
Right, but also, whenever you test your materials, go back here. Because there might be people back here. And make sure that they can actually read the text. Right now, I couldn't read the Tableau text, for instance. It's also rather faint, so it's not perfect. So make sure it presents well if you're in the first row or in the last row. And there is a sign-up sheet going around also in case you want to have your participation registered.
Yep, and we can of course give advice like that and test with you. That's time. Now I think we're going to walk over to the Innovation Center. On the way out, we'll take a really quick look at 2 other visualization devices that we have just out there in the lobby that you may have walked by on your way in.
Yeah.
Yes? Okay, I'm going to tell you up here.
Say something about it.
So this is the biggest version of the Microscope Kiosk display. And this is actually a collaboration between CNS and the Advanced Visualization Lab, which just gave us a really great tour. Ultimately, you have 12 macroscopes on here. Macroscopes are tools that are kind of like telescopes and microscopes, but instead of making them large or making them visible to you, even though they're far away out in space, these macroscopes actually help you see structure and patterns and trends in data. And so this, for instance, is Wikipedia data, and you can click on any of these and you will get to see a story. But you can also always go back, and here now you have to really walk over to go to the home screen. These are the 12 macroscopes, 3 years. This is a 10-year effort, so there are 7 more years to come, which will add more and more macroscopes. We are just right now actually reviewing the 14th iteration, and so very, very soon you will get another set of most likely 4 more to be displayed here. Ultimately, what we envision is to have this macroscope display surrounded by 100 maps of science, and ideally we would have 12 of these large displays. Of course, somebody has to finance this, so we don't have that yet. But then you would have the interactive data visualizations in an inner ring and 100 maps of science surrounding it. And that would be a nice exhibit to bring to many, many public places in the US and beyond. But for now here, you have interactive science, which was the first iteration of macroscopes. And you have, for instance, Earth. And on Earth, you see all kinds of different data in a very beautiful way. And you get a little bit of information, but you can click anywhere to make it go away. You have a menu which you can use to, for instance, look at not only ocean and weather patterns, but you can also look at particulates, for instance, which shows you kind of how clean the air is around the globe. And so you can navigate to your favorite country. And sometimes it's good, but in the summertime you will actually see a lot of interesting areas where you have either a lot of sandstorms or you have really a lot of industrial pollution going on. And ultimately it's almost real-time data which you see here. So my husband, he went back to US and he zoomed into Bloomington, Indiana, right? So you can zoom in. And he waited a while and he's like, well, can I go windsurfing tomorrow or not? And so he used it in his own way, right? So everybody might have a very different way of interacting with it. And so I guess we would need air, and we would get to see what it really does in real time. Going back, you can pick your favorite piece. You can look at the news co-occurrences, you can look at global traffic patterns, you can look at the map of London and what kind of smells you might have if you go to different areas. So if I click in any of these areas, let's click in a green one, which is actually a nice one, you will get to see that it's mostly nature smelling. But there might also be some animal smells, which is a bad smell. And then there might be others which you can then explore. You will also get a sentiment analysis of all the tweets that have been tweeted there. And so you see that's mostly kind of joyful tweets in a green environment. But if you go into other areas, let's go to a red area, that might actually very quickly change. I think it's a lot of data, yeah. You can also zoom into your favorite area and you can check out, oh, do you really want that hotel there where all the happy, joyful tweets are? Or do you want it in another area where you have a lot of traffic passing by and maybe not so great? All right, so another one which you might be interested in exploring is mega regions. If you would have to redraw the state boundaries, how would they look like based on commuter patterns? As you know, many people in the US drive long distances to get to work and back home. And so here now you can go in US and you see us here and you see that Chicago acts as a huge magnet. So many people travel in from Gary and from other places. Also for Indianapolis, so you see how long distances some people are navigating. But you can also zoom into other places that might be interesting to you. And ultimately, you get a new kind of geography of the US just based on this very, very rich data. Any questions? Yeah. No, this is a canned data set, so this is not real time. Yeah. See, right?
We should, unless you want 2 seconds on the science on the sphere.
Yeah, go for it.
Okay, so if you turn around up here, this is called the Science on a Sphere. This was developed at the National Oceanographic and Atmospheric Administration, and obviously it's really good for visualizing spherical information or information that occurs on a globe, which naturally are environmental factors that we have. So similar to the wind map that we had playing in there, this is sea surface temperature and currents. And these can be near real time. This particular data set's older, but they can get data sets to us within about 30 minutes of the sensor acquiring that data. And the sensors, there's whole networks of buoys on the ocean. Of course, there are satellites that can measure all kinds of things. So here, they've got legends around the sphere because there's no front. There's no front or back. There is a top and a bottom, but no front or back. So you could have people looking from over here or over there. So they have to be careful about putting the legend all the way around. Now, this one is also somewhat interactive. We have a kiosk over here. So if you have a particular interest in whatever's going on right there, there we go. You might want to be looking closer to the North Pacific and the North Atlantic. So it's just a different, interesting way to visualize your data in a way, especially depending on if the data is planetary in its origin. It really helps to project it and display it in a way that recreates that shape. So you understand, because when you're looking at a flat map of projection, one, there's distortions on there to make it work, and two, your brain has to do some gymnastics to remind yourself, if this piece of information I'm following goes off the right edge of the map, it reappears on the left edge. Or if it goes off the top, it comes back in a different place on the top. It doesn't loop around to the bottom. So, you kind of have to be somewhat trained to interpret the data through the distortion going from a spherical projection to a flat projection, because you are introducing a distortion. And for lay people, or folks in audience that you might be presenting to, that's a lot of mental gymnastics that you have to train them on. Whereas here, it's taken care of, because it's a more faithful presentation of the data for data that is round. Any questions? Yep. Well, we can help you get data sets on here as well. There's over 1,000 data sets. We've contributed several for various events like the Olympics, Summer and Winter Olympics, World Cup, as well as some researchers who are studying. The problem is a lot of research is done in a regional area, and they're thinking, oh yeah, we're studying the migration of bats in southern Indiana. That's wonderful. That's lovely. It's very important to bat lovers and bat researchers. But Indiana itself is about 1/10% of the surface area, and southern Indiana being a third or a quarter of that. So now it starts getting to be like, southern Indiana is like maybe 4 pixels on that whole display. So you got to think big for the Science on the Sphere, because the world is big. We've got 7.5 billion people on this place, and it's just physically big anyway, so do what you can. Okay, good to go? All right, we are going to take a stroll down the sidewalk there over to the Innovation Center, where we have another visualization facility. Any questions? All right, bring your coats and bags and stuff, because you probably want to leave from there.
But here we're going to show 3 different technologies for virtual and augmented reality. So Chris is here with us again, and we have a new staff member, Ed. Hello, Ed. So up here, this is a 3-screen projection system. This is a kind of a classic VR setup, except usually they have a 4 in addition to the wall screens. Hello, welcome, come on in. Typically, this is a stereo display that is tracked. In today's case, we're presenting just for monos, like multi-glasses. Ed, over on that side of the room, is going to show the HTC Vive head-mounted display VR system. It's a more modern, consumer-level VR display and much more important. And then Chris is going to demonstrate for you augmented reality with the Microsoft HoloLens. So there's Chris with the HoloLens on right now. Chris, Chris, whatever demo time comes in 30 seconds, probably wander over closer to the mirror thing. So, anyway, it's going to be free-form demos. So there are 3 stations. I'll be up here and over there, Chris back there. Just wander around, get a taste for all of them. And again, let us know if you have questions or if you want to use these things for your work. Let us know. We make them available to you. So for real, someone needs to stand up.
This is the interactive portion.
Like, you all need to stand up.
So come on over here if you'd like to see the HoloLens. Up there if you want to do VR. And you can do them all. Absolutely do all 3. Just take your turn, just take turns. You ready?
Sure.
Yeah, so you're going to get this on your head, and this will tighten and loosen. You want this firmly on your head, and then your nose will just rest right there.
Small crowd.
There you go. It's a little front heavy. That's just the way it is. So if you look around, you'll see some well, they're not really holograms, but you'll see some visualization that's already been placed by my colleagues here. There's a space shuttle up near the ceiling. There's a mime over there. You got a little park.
So this is a Hololens.
There you go. And these are all somewhat interactive. Some of them have animations, and some of them you can move, resize, and adjust. I've not gotten a really good practice at doing that. Because a lot of the way to interact with the HoloLens is to make sure that your hand is visible in the camera and doing that. Because that will select things. Yeah, there you go. And you just got the mime to animate.
I was going to say, you're trying to select her?
No? Well, sometimes, that's part of the trick with augmented reality is the more sophisticated systems understand that there can be objects that occlude or that should occlude the virtual object. And some of them some systems are better than others at handling that occlusion. So the HoloLens is constantly mapping the environment. So this is an inboard tracking system. It's using IR sensors and cameras to figure out the geometry of the space. Oh, there's a little T-Rex up there.
I'll drink.
And then in that space, so we've placed like the fire over there, and we've placed the mime over there, and placed the T-Rex up there. And the system is continually updating its position and where it is and where the objects that were placed are, so that they stay registered with where they were placed.
So, sorry.
Yeah.
Where's the processor for this?
It's on the HoloLens. This is completely inboard. We're using this laptop as a receiver. Basically, it's just doing screen scraping, using it like a VNC protocol, and sending over to that laptop to just display as an external display so people can see what's happening. But it is independent.
Okay.
Yep.
I was just wondering because the rendering capabilities are a little limited.
It's all on board. Yep. All right. So you ready to try?
Sure.
Absolutely. Yep. Just get it on. Tighten that.
Here, and you can see it's following my head as I move around. So like those are his eyes, I guess.
This body over there.
Is it noise or?
The cord, it's not noise, it's... See, he's got like... I do not know what that is, but it's not noise, it's rope or
Is it
something.
the human body, the scientific visualization, the person who volunteered?
Yeah, it's called the visible human.
It's the same, yeah.
Visible male.
He's a visible, yeah.
I'm just wondering about this cord. What's that?
I do not know what the cord is.
Yeah, it's actually the visible. I can do it all day. What was it called? What is it called?
Visible human? Visible male?
Okay, so it's a person actually he has volunteered to.
Yeah, he said when he donated his body
donate his
actually.
body, and it's
For
used for scientific
scientific
visualization.
Good.
Yeah.
That's what we have that.
entire bodies and we showed on the first class of the
That's what we want.
This is only the hand.
And as we sweep further and further, we can see now we're picking up a skull. Get a good look at the skull.
This has been coded to get to this level, right?
Yeah.
Yep. Yeah.
That's just going to transport you somewhere else.
Oh, I'm sorry. It is really tricky to hit the right thing. But yeah, this is
I
the.
think from a doctor perspective, how effective this tool would be for doctors.
Yeah.
So the application, I mean, so medical science.
Medical science applications.
You can see as you go more and more dense,
It's good, the big screen.
the densest parts of the human head are the teeth and the jaw and the inner ear. Yeah.
One or more
And one of the other capabilities of this tool is say isolating part of it that's like really dense. I can give that a different color. Put a little lipstick on the guy. And then grab this. Put it in context a little bit. Okay. There's the skull, and there's where the dense parts are. He's got something in his mouth too. I don't know what that is. So anyway, that's
Yeah.
Yeah.
VTK.
Yeah.
If you're having some discomfort, of course, always take a break in between.
come up on one of the screens.
And when you're in a VR system like that, sometimes you need to
Here we go.
look down or look
So this is
away
a similar application, only instead of for volumes, this is meant to show point cloud
So you
data.
just have to.
So in this case,
I've heard it's gotten faster.
so we've just
It's like a game.
yeah. This is a real place. It's not a game.
It's very familiar.
It's a temple somewhere.
It's in Europe somewhere.
It is in Europe.
Yeah, it's
Not the
I've
Stonehenge.
seen in some movie.
Sorry.
Sorry. It's very famous.
Yeah.
It's in Greece. No?
Italy, I think.
Oh, sorry.
This was captured by a team of Indiana researchers, although I'm sorry, I don't have a great deal of information about it. But, this was captured by just taking photographs. So the technique is called photogrammetry. You just wander around the space, you take thousands of photos, and then you process them, and it's able to extract all of the points in the various pictures that match up, and then construct the 3D mesh from all those 2D photographs.
Did you guys plan to visit India? Because you have a lot of good, those old monuments and they have 3D effects.
Yeah.
Yeah, you guys must plan. Especially there's this place in South India.
Yeah.
It's age old, I don't know how century. So you know how many years old? The Vijayanagari. It's so 1800, right? So it has 3D effect.
Write up a grant, get some money, and go scan it.
Yeah. I can do it like that. I can go back for my holiday and I can just get the print.
So I will also see if I can pull up a quick demo here of an analysis part of this tool. Let's see, do I have it? So I can paint part of this wall. Wrong button. Wrong button, there it is. So I'm just going to paint a little of this here.
You're defacing a monument.
Yeah, I know, right? But if I'm doing this because I want to see if this wall is level for some reason. Like I want to see has it wobbled over time. Now let me see if I can pull up. Oh, it looks like I hit the wrong button. Oh boy, I've done it again. Okay, hold on. So what I want to do is I want to fit a primitive shape to this thing I've just selected. So I'm going to extract a plane. And now we can see that it has attempted to fit a geometric plane to the points that I just selected. And if I pull up the right part, you can see that it is computing some kind of values and despairing them. I'm not. These are, what is the angle of the of the plane that I just
Yeah.
made.
I have a hard
I'm not perfectly clear how to read it exactly, but you get the idea. You can select parts of the mesh, then you can
Can you
try
cut
to-
out a block in this
Uh,
like Armin did?
I'm sure that you can. I can't right now on the spot, but yeah, I'm sure you could. So, anyway, those are.
See-through.
And you want to get that optical path to go right into your.
Oh yeah, these are
Going into
just
the wall.
these are points, right? So there actually is no physical wall there. It's just points that are kind of aligned to look like a wall. And in fact, I can manipulate the points.
You will see something.
Rendered.
It might be a blob. I'm also nearsighted.
So I can like change the size of the points, make them real tiny, so everything's really see-through now, right? Or I can make them like cartoonishly huge. Let's see, now things are like these big discs.
Sequence.
So
Yeah, like
Sequence
sequence.
is very useful for bringing up metadata information. On
So
objects.
these are
So say you have,
really the kind of bread and butter of the scientific visualization in VR that we do here. So I have other data sets I can show, or really you probably need to make your way around to the other stations. But if you want to check it out and stick around, feel free. Otherwise, go see some other VR, go see some AR.
is connected with whatever sort of power system.
Oh, this
So
is cool.
Blinking this thing right here, pull that. And it might be pull it out 2 inches, rotate it 90 degrees clockwise, and then you continue to pull it out in order to do that. So that's what well, everybody understands that visual systems are by their nature and visual, because we have, most people have, there's a variation of what's called interdisciplinary separation or interpupillary distance, which is a measure of the optical phase of your eye. And this system is fairly fixed. These little helical mirrors and projectors that are in here, there might be a little, I was seeing mechanical adjustments, electronic adjustments, shift to get into a so that won't necessarily handle
Thanks.
difference between